yesterday in your Desmos activity, you graphed circles. Well, you toyed around with circles, rose curves, and Limousines, right? Okay. What did we figure out about circles? Okay, well, there's 3 different ways you can make a circle. R equals A means our radius is always A, or our distance from the origin is always A. So we have a circle of radius A. But yesterday, you went through these types of circles right here. We have R equals A sine theta. Our circle is going to go through the pole. It's going to be tangent to the pole. A is going to represent its diameter. And it's going to go which direction from the pole? Okay, it's going to be vertical from the pole. So if A is positive, then it will be above the pole. If A is negative, this circle would be below the pole. R equals, whoops, I forgot the A. R equals A cosine theta means we have a circle, once again, tangent to the pole. But this time we're going to go horizontal. And if A is negative, we would be to the left of the pole. Correct me if I'm wrong. We talked about these graphs at the end of last year.
Like 2021 or calculus AB?
Calculus AB. Okay. Sorry, last school year. That's better.
You call them poles, they're not like axes.
So this right here, the origin is the pole. And we have a horizontal axis and a vertical axis. If you call it the X and Y axis, I'm not going to be upset. But instead of the origin, technically it's the pole. Hence the name polar coordinates. All right. I'm actually going to skip to rose curves. Circles are a special type of rose curve. So there are 2 different ways for us to get a rose curve. R equals A cosine of n theta, or R equals A sine of n theta. Okay, so let's talk about, these are the ones that look like flowers. What is A giving us? Okay, so A is the length of our petals. What does N represent? Number of petals. But it's really just not like super straightforward, is it? Okay, If n is odd, we have n petals. But if n is even, then we have to double n to get the number of petals. Now, what did you determine the difference was between a cosine rose curve and a sine rose curve, or really any cosine versus sine polar curve? This is true, they do start in different positions, but there's maybe like some sort of aesthetically pleasing aspect. Like some symmetry. There's symmetric about different.
Cosine symmetrical, like.
And why was that a good guess? Cosine is always associated with horizontal movement, right?
Like one, zero.
Okay, and anything with any polar curve with sine is going to have vertical symmetry. So let's even go back up to our circles. Notice how our circles that involve a sine theta are symmetric about the vertical axis. Our circles that involve that's exciting news for me. Okay. R equals a cosine theta is symmetric about the horizontal axis. ESPN just told me that Colin Klein got promoted to offensive coordinator at K-State. Colin Klein played quarterback for K-State, was the Heisman Trophy runner up to Johnny Manziel, who shouldn't have won it in the first place. And he has been grad assistant, now quarterbacks coach, and he was the offensive coordinator for our bowl game and has now been promoted. Well, you know, I feel like with good coaching and a better offensive line, he'll do okay. Nebraska's offensive line stinks.
Yeah, it's pretty bad.
Yeah. Okay. Are you offended that I stated facts? Okay. Okay. I also feel like his head's gonna be in a better place because, yeah. Then that stinks. Oh, really?
Yeah, like 4 quarterbacks.
I did not have any of the female white girls. I have Nate white girl class. Okay, Limousines. That is how you say it. R equals A plus or minus B cosine theta. R equals A plus or minus B sine theta. If you call them limacons, I don't care, but I'm going to pronounce it Limousines.
So is that one?
Yes. Now I do care how you pronounce.
Wait, Rachel was genuinely confused yesterday. Yeah, she was like, wait, how's the actual way that you say it?
Well, it looks like Euler, so it's Euler. Honestly, you guys have almost gotten me confused. No. No. All right, so in this case, okay, we have 4 different kind of Limousines. We have a Limousin with a loop. We have a limousin that looks like a heart. Cardioid. Did I do an extra eye? No, I think this is good. We have a dimpled and convex. My convex really stinks. That's better. It's like it doesn't indent at all. It's like a squished circle. Oh, these are terrible drawings, people. Those look better. Okay. When do we get a loop? Okay, better question for yesterday's activity. What causes us to have the different shapes? What do we need to look at in our equations? And yes. If A over B equals 1, we have a cardioid. So if A and B are the same, we get that cardioid. Where there is a corner, I bet that corner will come into play when we start our calculus on Monday. Like on Monday, we're going to start talking about polar derivatives. Okay, loop. A over B is less than 1. It's all coming back. It's all coming back to me now. That's a song. Evie has, she knows.
Oh, yeah.
Miss Crockett pronounced Reese's Pieces Reese's Pieces. She would have stopped. But then she said Reese's. Yeah, then she said Reese's Pieces like once. I think Reese's too. You know,
It's, we can be flexible, right? And look at me being flexible. Did I?
Oh, yeah.
I did?
Yeah.
Oh,
Our subs always, are they supposed to read us the sub plans? Cause I feel
oh,
our
like
subs
2
are-
days ago? I didn't put anything about Euler.
Oh, I don't
It was in the video. Yeah, it was in the video. As it is now. Okay. Yeah. Did Mr. Hazelhorse read you the sub plans? Or I said you better be. I said they are fine. And he said, Well, you're my wild card class. I'm never really sure what's gonna happen. Aiden, what kind of curve is this? You have three choices. Is it a circle, limousin? It's just a circle. And Evie, where is this circle? To the left, to the left. You know that one, right?
Shuffle.
Can we do the Cupid shuffle?
So that's totally not the song I was talking about, but. Now, what if I ask you to find the zeros? We are in polar. So when I'm asking for zeros, I want R to equal 0. So when we divide by the -5, when is the cosine equal to 0? So this is how this circle is getting constructed. When we plug in 0, our R value is -5. So -5, 0 is this coordinate right here. We rotate to pi over 2. Excuse me, we rotate to 0 pi over 2, and then we rotate to 5 comma pi. So just to make this one circle, we only need to worry about the one time it goes through the pole. Okay, so there are a lot of options for, don't laugh at me. There's a lot of options to where thetas we can plug in and R is 0. But if we're just talking about like the one simple time that we draw the curve, we go through the pole one time. That's the only one I want. No, you made me laugh first. I sound like a couple who can't get off the phone. No, you say bye. No, you hang up. No, you hang up. I have no doubt. Do not make me regret my decision of the seating chart.
You know what popped up in my staff members the other day is that it's a picture of me, Grace, Nikki, and Grace Castle. And we said, Mrs. Holman really made a mistake with this one.
Mhm.
And looking back, you did.
I did. All right. Grace, what kind of graph are we dealing with here? A rose curve with how many petals, Dane?
4.
Okay. Here's what I need you to do. I need you to make an R theta chart. And we are going to first plug in 0 for theta. When we plug 0 in for theta, we get 2 cosine of 0. And the cosine of 0 is 1. So at 0 radians, we need to go out, oops, 2. Now, that's all we need. We know that this is where one petal is going to be. we know that we have 4 petals. How far apart will our petals be? It is, or 2 pi divided by 4. Okay, now watch me draw this, and please count the number of times we go through the pole. Ready?
1, 2, 3.
Do I need to draw it again? So we're going to find all 4 of these zeros. What? Yes. All right, so we are going to set R equal to 0. Maybe see why I gave you the assignment on Wednesday that I did. So we divide the 2 over, we have the cosine of 2 theta equals 0. Now, this is what we're going to do. We know that the cosine equals 0 at pi over 2 and 3 pi over 2 and 5 pi over 2, and we can be obnoxious, right? We want 4 zeros. So I'm going to set 2 theta equal to the first 4 times the cosine is 0. So the cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. There we have 4 numbers. So when we divide by 2, our zeros occur at the pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So what I care about is that you can graph and find zeros.
Yes.
Here's where, so I know that we learned this last year, and I could totally just skip right ahead to doing all of our calculus stuff. But eventually, I'm going to ask you to find the arc length of one petal or the area of one petal. So in order to be able to do that, you need to know where one petal starts and stops. So I know that one petal starts at pi over 4 and ends at 3 pi over 4. That'll be helpful when we set up an integral for arc length or area. Okay, it's so great.
Oh, yeah.
So great. Disappointing, Grace. I'm mocking you. No. We always start where theta is 0. So we're gonna go over. Do you want to do that one before we do the Limousine one? Okay. I am gonna do a sine rose first. Let's talk about our Limousines. Limousines are the easiest to graph. When you're graphing a Limousine, Grace. Grace, give Jane a compliment, please.
You didn't even hear what I said.
When you graph a limacone, you're gonna plug in 0, pi over 2, pi, 3 pi over 2, and 2 pi. Yeah. Before we graph this, Evan, what kind of limacone are we gonna have? A dimple. Okay, this is a dimpled. What's the sign of 0? What's the sign of pi over 2? Oh, hold on. 4. How about 6? So on our dimpled ones, please make sure that there is no like sharp edge. It's very smooth. It's like the Pillsbury Doughboys belly button. You've seen the commercials where he, right?
Yeah. It touches belly button?
You don't know what I'm talking about?
That was just so out of it. I don't know what you're talking about.
You guys don't watch commercials, do you? Okay, you have a ball of Play-Doh and you push it a little bit and it kind of just makes a little groove. That's what that should look like. You really don't know the Aiden, where are the zeros? I feel like you're gonna have the best answer for this. Yeah. Where do we intersect the pole? There are no zeros because we don't go through the pole. Don't have to worry about them. The only ones you're gonna have zeros on would be the cardioid and the loop. This is our last example. Patrick, what kind of graph is it? A rose curve. Evie, with how many petals? With 4 petals. These petals have length what, Dane? Awesome. Now, when we graphed our cosine rose curve, we plugged in 0 and it gave us where our first petal was. But you guys have already told me what happens when we plug in 0 here. We get 0, we start at the pole. Well, how do I know where to put our first petal? Okay, well, we know how long it's supposed to be. How long is it? 4, which means the R value is going to be 4. So if I come up here and I take 4 and set it equal, right? And where is the sine of theta equal to 1? Once you know where to put your pedal, then you don't have to do any more work because you can just evenly space them apart. How do we draw it? Well, where do we begin? We have to begin at 0, 0. Okay, so everybody watch me draw this. I'll draw it slow, so hopefully the lag isn't too bad. And count how many zeros we have. So I'm going to begin.
1, 2, 3, 4, 5.
It doesn't matter in which order you draw these. Just understand that we went through the pole 5 times. You don't know how to draw pedals? Sure. Find me the 5 zeros. Ready, set, go. Are these your 5 zeros? Okay, give a worksheet today. What's his fault? What's his fault? Evan had a bowling go yesterday.
Oh, it went pretty good. We won.
No, just for scientific purposes. That is literally ancient. I don't think they do that anymore.
They don't?
No. I don't know.